So in looking at our task summary here, we are looking at different scenarios and you had to order them. So first, what I did, I decided if you're draining the pool, that has to happen first with a hose. Then you're going to use water buckets, three of them. And then eventually it's going to get low, so you're going to have to only use one. And then after that, if the pool is empty, this would be your fourth task. You're going to clean it, take a break to let it dry, and then fill it. Remember, you could have had a different order and then that's fine. So here's where I sketched my graph. Here's the water coming down. Then eventually you're emptying it with three buckets and empty buckets. Then you take a break and then you fill it up at a constant rate. Now, what I want to talk about here is if I put in some units. So I'm going to put time. This is 0 hours. And then I'm going to count every 2 hours. I'm not sure how long it would take to empty a pool because I don't have one. But maybe 10 hours. I don't know. So on here, the X values here, that would represent the domain. So to say that, we can say X is less than or equal to, it's between 0 and 10 hours. So that symbolically is one way that we can say that X is between 0 and 10. You also could use this notation that you might see. X can be 0 and it can be 10. And you would put the brackets around it. And then if we talk about range, I'm just going to talk about the gallons of water in a pool. And again, I'm not really sure how many gallons of water a pool can fit. So I'm just going to go 50, 100, and call that 150. So if we did the range here, the Y value is a range. Y is between 0 and 50. That's one way to show that. And I need less than or equal to there because it can be equal to 50. Or if I put that in the bracket notation, you can put it can be equal to, it's between 0 and 50 gallons. Other points that we need to talk about. We have key features of the y-intercept. And I'm just going to put y-int for y-intercept. And the y-intercept is the value 150 for y. Now, we need to express this as a point. So if you notice, that's when the x value is 0, y is 150. So to express this as a point or an ordered pair, we'd put 0, 150. And then the x-intercept, this would have multiple because it's touching the x-axis for a while. So we're just going to say when it first touches, we'll say that's around 4.5 hours. So 4.5 for x. And then if you notice, the y value is 0. So I'm going to put 4.5 and then 0. And I'm also going to list this over here. We'll just estimate that to be 7 for x and 0 for y. We're going to add in and talk about intervals of decrease and intervals of increase. And when you talk about the interval of decrease, the water decreases from about 0 to 5 hours. So I'm just going to put for x, that's between 0 and 5. And then the interval of increase, I'm going to say from about 7 to 10. Now to create a story, I just made up a story. Yours could have more details, less. So I just said, Sylvia removed the water with the hose. Then her and her friends used bucket to remove what the hose couldn't get. Eventually, they only used one bucket. Then they cleaned the pool, took a break, and filled it. So here, does your graph represent a function? Why or why not? Would all the graphs created for this situation represent a function? So yes, it is a function. Every time input has only one water output or it passes the water test. So what I mean by that is if I go up to this graph, every time I have an ordered pair, the water value is only going to be at 1. And a test for that is if I draw a vertical line through the graph, it only crosses one time. So that's our summary.